All right, let's get back over here to the next topic. We're going to be taking a look at a concept known as mGRE, and then we'll take a look at DMVPN. All right, rather than doing get VPN, we'll do extra stuff with DMVPN. We'll do a lot of different stuff with DMVPN. So first of all, what is this mGRE part? Why do I need it? When we set the tunnel interface up, whether the tunnel interface was set up based on the default GRE or when I changed the mode to IPsec, one thing common among the two was both of them were point-to-point setups. So the tunnel interface that I used to add that dynamic nature to my network so that I could add new networks to it still has a limitation. What's the limitation of this tunnel network by default? The tunnel interface is what by default? Point-to-point by default. And the drawback, the disadvantage of that is scalability. Okay? If I had a lot of different sites that I wanted to connect up to each other directly, I would need to create multiple point-to-point circuits or tunnels to connect them up. So if I wanted to connect everyone to everyone over here, I would need tunnels like that. So 4 tunnels on R1. I also needed R2 to connect to R3 directly through the internet. So I need a tunnel over there. Actually, I'll take this cloud out. Otherwise, it just, as is, there's so many tunnels. So I'll go from 2 to 5 and 2 to 4. I'm already going to 1, so 4 tunnels over there. Then I'll need tunnels over here as well. I have 2 tunnels already. I'll have a tunnel like this. Tunnel like this. Well, that one I already have. I'll have a tunnel over here. And then 4, I have 1, 2, 3 tunnels. I'll have a tunnel like that. So a bunch of different tunnels. So on each one of those routers, I'll have 4 tunnels. Why? Each one is a point-to-point tunnel. So to get around that, what the Cisco router does, it gives you the capability of creating the tunnel in which the tunnel is a multi-point circuit. Multi-point means it's a single network, single tunnel with multiple points on it. So from a tunnel perspective, all of them will be connected into this logical tunnel interface. A single tunnel network with multiple points on it. All right. There are challenges that come up when you do that, and we'll take a look at that. And this type of tunnel, which allows you the ability to do multiple points on it, is known as a multi-point GRE tunnel. mGRE. Good so far, guys? Everybody okay with this? I want to connect the different sites to each other over a common network. So let me bring up another diagram over here. I'll copy it into your folder from the previous class. Where is it? This one. It just has 4. Let's go to 11. 11 might have more. Yeah, this one is better. Copy. And I'll put it into your folder. Second. This is number 15 now. There you go. All right. So this is what I want to do here. Oops, one sec. All right. Let's go back over here. This is what I want to do. I have this as my internet. I want to connect these 4 sites, R1, R2, R3, R4, actually 5 sites, to each other over a common single network 192.168.1.0. You guys understand that? By doing this, I have a single tunnel with multiple points on it. And that's what a multi-point GRE tunnel is. Good so far, guys? Everybody okay with this? All right. Everyone? Yeah? Give me the yeses, man. More. There you go. All right. So to do that, the first problem that you need to understand is the problem of mapping. When I did that point-to-point tunnel between 2 sites, that 192.168 network that I had that connected me to the other side over the tunnel had one destination. So from here, any traffic that went to tunnel 1 would be sent to whom? 20.2. Okay. Any traffic that went on that tunnel network, the outer header, because there's a point-to-point tunnel, means there's only one destination point. You all good with this? So if I had an internal packet, I didn't care about where it needed to go as long as my routing table says go to 192.168.1.0 goes through the tunnel. The tunnel had a single destination. I knew where to go. But if I have a multi-point type of setup now, it's not just R1 and R2 that are connecting to each other. I have other sites connecting to this tunnel. I cannot say tunnel destination 1, 2, 3, 4. For example, let me just show you that. So I have R3 and R4. This guy is, let's say 30.3 to keep it simple. All right. And I want to join them all into one tunnel network. .1, .3, .4, .2. So if I'm sitting over here and I say ping 192.168.1.4, in my routing table, there's only one interface. That is the tunnel interface, which is 192.168.1.0, which is via the tunnel. Now, when it goes to the tunnel, where does it send the packet to? Yes, it matches the routing table as 192.168.1.0. Where does it send the packet to? Does it send it to a tunnel destination of 10.1, 20.2, 30.3, 40.4? Which one? I cannot put 4 destinations because if I did, I want to send a packet to him, it's going to go to all of them. So what I need is a mapping agent that allows me the ability to specify if I'm sending a ping to a network or to an IP of 192.168.1.2, my internal header has a destination of 1.2. I want to send that packet on the outside. I need to do some type of map that tells me what the outer destination should be. So I need to say, if I want to go to this on the inside, the outside address for this guy is 20.2. This is done by a protocol by the name of Next Hop Resolution Protocol. NHRP. And this database, this mapping table, is known as the NHRP table, in which I would need to define, if I want to go to a particular destination, what is the public address of it? Based on this, now when a packet comes in into my router, I would need to look at my NHRP table and figure out if I see a specific address on the inner destination. This is your inside destination. What should your outside, meaning outer header, look like? And that information is derived from this NHRP table. So whenever you use mGRE, what comes hand in hand with it? NHRP. You cannot have mGRE without NHRP. So over here, where the packet was meant for 1.3, it goes in, checks over here, 192.168.1.3 is 30.3. Based on this table, it puts the appropriate outer header. Everybody okay with that? You guys understand what NHRP is doing for you guys? Yeah, okay. So what I'm going to do over here is let's set this network up where I have router 1, router 2, 3, 4, same setup. I want to connect these 5 routers into one single tunnel network, which is 192.168.1.0. How would I configure that? Let's take a look. What number was this? This was 6. So this would be 7. Multipoint GRE. So R1. I'll create a tunnel interface tunnel 1, IP address 192.168.1.1. This is my tunnel IP. Tunnel source, I could either do 10.1, or to make it simple, I'll just say pick it up from E00, which is my outside interface, which is 10.1. And normally I would have said this. You guys agree? And specify the address. But now I have multiple addresses. I don't do that. Instead, I change my mode because it's a multi-point interface. I want to make it into a multi-point interface. What's the default encapsulation? The default encapsulation or the protocol is GRE, but what they don't tell you is the protocol is GRE point to point. It is not GRE multi-point. It's GRE point to point. Although when they say GRE, it just says GRE. It doesn't say GRE point to point, but know in your head that it is GRE point to point. I need to change that. What do I need to change it to? GRE multi-point. All right. So I'm changing the mode from GRE point to point to GRE multi-point. In order to do that now, I need to enable the NHRP protocol. How do I enable the NHRP protocol? IP NHRP, network ID, and a number, a process ID. It's locally significant. It's like saying router OSPF 1, locally significant number. Any number, doesn't matter. But this command, what does it do? It's a very important command. It turns on what? NHRP on the interface. All right. Required, the number is insignificant, locally significant, but you need to put a number there. Clear, guys? Everybody okay with this? Now that's done. Now I need to do my mapping. Now looking at this topology over here, I'm going to have 192.168.1.2 for router 2, 1.3 for router 3, 1.4 for router 4, and 1.5 for router 5, correct? I need to map whatever destination that I have using the NHRP map command. The way I'm going to do that over here is IP NHRP map. If I have my inner destination as 1.2, the public address for that guy is 20.2. If I want to reach 1.3 or 4 or 5, their public addresses are going to be 30.3, 40.4, and 50.5. So if somebody tries to ping 192.168.1.3, for example, it knows, it checks a routing table. And in the routing table, I'll have one network via tunnel. It's just going to be one network. When it sees via tunnel, it says, okay, the source address of this packet destination is specified. Source is going to be the source address of the interface, the tunnel interface, which is 1. Destination, I'm going to put based on the ping that I had. Now it goes through the tunnel. When it goes through the tunnel, it needs to do the encapsulation. Source I specified, get it from the interface. How about this guy? That's where this comes in. It analyzes what? The destination over here, checks it, says, oh, this is the corresponding destination address, puts it over here. So what's the purpose of the map? Is basically the mapping. All right. As I said, it enables NHRP on that interface. It's the enable command. I actually wrote it for you. Remember this? I just wrote it 2 minutes ago. Good. And that's it. That's your config. Copy it. Let's go to router 1. I need to reopen it because I had stopped them. All right. So let's go to router 1 and paste it. Now, as soon as I do that, check your routing table. You will notice that I have a new network, which is the tunnel. If I go into the tunnel, I've changed the mode to what? Multipoint GRE. As soon as it sees Multipoint GRE, it knows automatically that it needs to have an NHRP mapping table that will show me the mappings. If I want to reach this network on the inside, this is the address on the inside. This is the outside header. If I want to reach this IP, this is the outer header. If I want to reach this IP, this is the outer header. Got it? And what do I do on R2 then? If that's the case on R1, what do I do on R2? My IP is 1.2. Network ID doesn't matter. 11, 1, doesn't matter. It's locally significant, but you need it to enable NHRP on that interface. I don't need a mapping for myself. I do need a mapping for 1, which is 10.1. I do need a mapping for 3, exactly the same. 4 and 5, exactly the same. So I can just copy this onto R2. Paste. All right. And now show IP route. I have that new network 192.168.1.0. If you look at the tunnel, shows you it's mGRE. That means I need to have an NHRP table. Show IP NHRP. And it shows you what? The mappings. At this point, can I go from router 1 to router 2? If I type in on router 2, I type in ping. Let's go through the process. 192.168.1.1. It creates a packet. Now the destination I know is 192.168.1.1. It needs to figure out what the source is. Checks the routing table to find out what the outgoing interface is going to be. In the routing table, it matches this network as the destination, says it's directly connected. So directly connected, it uses this as the outgoing interface IP. Up until now, normal routing, but then it sees what? The tunnel. Says, oh, I need to go through the tunnel. Sends it to the tunnel. And what does it find at the tunnel point? If you go into the tunnel, it sees that what? Before NHRP, you'll see that it is a mGRE tunnel. Because it's an mGRE tunnel, it says, oh, I need to use NHRP, but also at the same time, it does find out that it's a tunnel. So I need to put a outer header encapsulation, and the source address is going to be this guy. Now I need to find out the destination, which is in the NHRP table. So I go and check my NHRP table. And what do I see over there? To go to 192.168.1.1, which is this guy, this is the outer header. Maps it, puts it over here, and forwards the packet. And the ping will work. Although the middle router, router 6, has no idea about these tunnel networks. Understood, guys? All right, let's finish the other ones up. So let's do 3 real quick. Three. I have 1. I don't need 3. I do need 2 though. I need 4 and 5. So 3 is done. Everybody following, guys? So 3 is done. Ping 192.168.1.1 and 1.2. Let's move and do 4. I need 1, 2. I don't need 3. Sorry, I do need 3. I don't need 4, and I need 5. It is still GRE. It's just multi-point. It's not a point-to-point GRE. It's GRE. So it's still clear text. So that doesn't change. So I would need the IPsec GRE over IPsec type of thing to make it work. So 1, 2, and 3 are working. 5 is the last one. 5, and this is going to be 1, 2, 3, and 4. I don't need 5. That's myself. So let's see if I can ping them. All of them. Yeah. Advantage. Cuts down on the number of what? Tunnel interfaces that are required. Disadvantage. Not scalable. Right? One of them, right? Why is it not scalable? If I have 20 sites, how many maps do I need to do on each one? 19 maps. Yeah? Yeah, I don't need 19 interfaces. I need 19 maps. Number one. Number two, requires each site to have a static public address. What if one of these sites over here has a dynamic IP? What do I map to? Do you understand that? So two major disadvantages or shortcomings that you have are what? It's not scalable. Why not? I need too many maps. Number two, each site would have to have a static public IP. Everyone needs a public IP, but you cannot do dynamic over here, because if you have dynamic, let's say site 3 is dynamic, every morning somebody needs to come in and do the appropriate mapping based on what their IP address is. So every site requires a static public IP, which is expensive nowadays. And the third one that somebody mentioned is security. Security because of what? Inherent GRE. It's still GRE, so it's clear text.